Put in the screws in, put in the screws in. We'll have it all up about finished on this one. Let's go nice and deep. There we go. Should I insert a side cam here? Side black current hat. Nah, PS BRB. Should I insert a side cam here? I don't know. Kind of gets in the way, although there's a big gap at the top there, so I could do insert video capture device, side cannon. Whee! Here I am. Let's just go smaller on there. Maybe like just the face. Bang that up here. There we go. That's alright, there we go, that'll do. Evening gents, and anyone else, ladies, everyone in between. Hope you're doing well. Welcome to the first live stream in quite a while. Just popping the top back on this Bassface 4-channel Class D. Got a few bits to look at this evening. How's everyone doing? Been a while, been a hot minute. Hope you're looking forward to festive season. Don't want to get demonetized on that one. There's just some Robinson's orange juice here. Sorry, some Ribena. It's got some nice Ribena here. The bots are watching. How have I been? Yeah, I've been very good, thank you. Fantastic. Feeling great. Yeah, having a great time. Loving life. How's everyone else doing? Hope that you are all in the same boat. All feeling good. How's your year been? Tell me, guys. I want to know about something that you are proud of that you did this year. Something that you're proud of, or something, a real highlight of your year. Because we're drawing to a close, isn't it? 2023 coming to a close. Give me a highlight of your year. We'll look at some of your guys' highlights. Where have you been so long? Bro, I've just been repairing apps. So when I live stream repairs, they take a lot longer than if I don't live stream repairs, and I've been absolutely crammed busy with repairs, so I haven't really had a lot of time to live stream. And the reason that I'm live streaming tonight, this evening, is just because I've got a lot of very basic, simple ones to bang through that shouldn't be very difficult. Fingers crossed. Famous last words. And I just kind of fancy some company. Thought it'd be fun to do a stream. I haven't done one in a while. Ben says, I won Indiana State Championship in Mecca Mod 2. Fantastic. Good job, man. That's sick. That is awesome. Tell us a little bit about your setup, Ben. Chris from Kenya, yo yo! Thanks for jumping on. My birthday is on Thanksgiving, 23rd, so in 2 days. I wish I got my amplifier for my birthday. Nice! I had no idea that Thanksgiving was in November. I thought Thanksgiving was in like the summer. Oh wait, no, that's Independence Day, isn't it? Man, I don't know these foreign celebrations and all that thing. Stefan, how's it going, my man? Evening. Let's have a little peek in here then, shall we? So this is a Bassface. This is a mono block. This is like the most like basic sort of Chinese circuits you can get, but they're really good value for money. So a little 1 ohm mono. Usually the thing that dies in these is okay. I was going to say usually the thing that dies in these is output FETs. So let me show you something entertaining I've just noticed in this one. So if we scroll in here, zoom in here. So we have little 2-channel, sorry, not little 2-channel, little mono. We've got the power supply here, okay? So obviously you've got 8 FETs in the power supply, and the output section is here. So it looks like at one point this board layout had 3 MOSFETs on each side. 3 MOSFETs on the low side, and 3 MOSFETs on the high side. But at some point in the board revisions of this amplifier, they decided, hey, we don't need 6, we only need 4 now. I mean, that cost saving can't have been much, but either way, they removed the holes and traces for the 3rd MOSFET, but they didn't remove the gate resistor. Oh wait, never mind, it's early days in the stream, I'm being a douchebag. That is not the gate resistor, that is the pull down. But there's definitely space there for the 3rd MOSFET, and I've seen ones of these with the 3rd MOSFET here. Actually no, you know what, on this side they didn't. No, I wasn't going crazy. On this side there is still a gate resistor here for the MOSFET that doesn't exist, and you can actually see the pads are actually still there. Look, if we scrape off a little bit here, so they kind of, yeah, there's like pads there but with no hole in it for the MOSFET. So that's where the 3rd FET would be on the high side, and there's still a gate resistor there for it. On the low side they removed the traces to the top of the board. Ah yes, but they'll be on the bottom, won't they? But it looks like they did actually remove the gate resistor pad, I think. Yep, 2 gate resistors there, no gate resistor on this one. So it's kind of like someone did a bit of a botched delete job on the you know, schematic PDF, whatever they use before they print these PCBs. It's quite funny. Ben says, I have a Solo X18 on an SFP 8K, but I'm only doing 3K in my class. Nice! That's a really cool combination, man. Those Solo X18s. Is that one of the older ones, or is that one of the new ones? I haven't actually seen anyone with one of the new ones in the UK at least. I haven't really seen any YouTube videos because I don't really watch audio YouTube videos. Watch all sorts of other bits and pieces. But right, dead output FETs as usual in these. So it looks like we have 1 on the low side and 1 on the high side. Yep, easy, easy. We can do these from the top of the board, no need to go from the underside. There'll be no damaged traces or anything on the underside of these. It's just literally an output FET pops and that's it. So we can easily resolve this one just from the top. Nice and quick. Let's grab the pliers here. It's the old version with the grey cone. Oh, that's really cool, man. Good job. How's the SFB 8K been treating you? Have you had it for very long? Have you had it repaired at all at any point? They're over here in the UK at least, they've been a bit hit and miss. Some of them have been relatively okay reliability wise, but there's a very high percentage of them that do just randomly give up for like no reason. The parts inside those are ran to their absolute limits. The drivers on the output side, they're 20957s, and they have a voltage limit of 200 volts, I think, if I remember rightly. And the rail voltage for the 8K especially is right up there, almost getting to 200 volts. So they're pushed very close to their limits, as are the output FETs as well. What's the orange tape? Yeah, so this is just a electrical insulator tape, but that has decent thermal properties, so it transfers the heat from the FET to the heatsink, but not the electricity, because that would be bad. These boards have very little thermal mass. The traces are not that thick, so it doesn't take long to remove these legs from the MOSFET locations here. Very nice and quick. Damien says, I think there was a previous message that I've missed. Damien says, hey bro, glad to hear you're doing good. This side I started to repair the DB Audio Extinct 12s and bought the recones, and 95% of the way just spraying the dust caps white. Nice, doing a little bit of customization. I do like a white dust cap. I tell you what, actually my favourite type of dust cap is actually the full coverage inverted dust cap, you know, like the bowl style. I think that style of like cone visually looks really nice. Like the Dayton Ultimax. I can't be one of the only people that loves how the Dayton Ultimax drivers look with the kind of carbon-ish effect bowl cones. They look so nice. They're kind of stealthy and like high quality finish, really, really good. And interestingly, over here in the UK, we have a brand called InPhase, and they've got a line of subs called the XT line, and the cones are all inverted bowl dust caps as well, and their carbon look, they kind of look kind of similar-ish to Ultimax drivers at a first glance, but and they're actually pretty nice drivers for the money. They're really good value. They perform really well, take a lot of abuse. They've been put together at the factory really nicely. I use one here in the workshop as my test sub for, you know, making sure amps are working okay, showing customers their amp playing. I use one here in the workshop, and it's yeah, it's great. Finally removed that fume extractor from your soldering iron. Kevin, dude, where have you been? I haven't had that fitted for about 5 years. I could do with fitting it back, to be honest, because the fumes and stuff from flux, etc., and a lot of the adhesives that I end up melting through in some amplifiers are very toxic. I do need to up my fume extraction game a little bit going forward. But yeah, the one attached to the soldering iron just kind of gets in the way. It's a bit restrictive, so I removed that, got that out of the way. Just need to, I need to 3D print something. I need to 3D print like a big kind of funnel mouth that just sits in front. So if you see the bench here, right, I've got a bit of space here, so I could 3D print like a big rectangular mouth here that sucks all the fumes away into there, like a nice powerful suction motor or something like that would be good, sitting under the desk. But then I don't know what to do with the fumes once they've been taken away. I'd obviously love them to go outside. That involves drilling holes in your wall or in the ceiling of this room up into the loft or something like that, which I can do. It just means that it's yeah, you're making massive holes in your ceiling, aren't you? And you know, if you ever want to go back and change the room into something else, and you've got to do a big repair job. And I know you can get like carbon filters and stuff, but I don't know, are they really that effective? Ideally, I want it to just bugger off into the atmosphere, really. Did you ever complete your tests on 3D printed boxes? So basically, Series 1 of Boom or Bust kind of fizzled out. The videos weren't getting the views that I needed for it to be worthwhile me doing. So yeah, I kind of just stopped doing videos on Boom or Bust. We weren't getting enough interest, really. But I'm toying with the idea of doing a Season 2 and seeing if I can pick up some more interest, maybe do it slightly differently, use bigger drivers, different drivers, or do it in a slightly different way to try and get it rolling a bit better than Series 1 was. Drop the exit hose out the window. Well, that's all well and good if you live in a nice warm country, but here in the UK you've got to keep the windows closed, man. It's like between 0 and 5 degrees Celsius out there, especially in the evenings, so you don't want to have your window open. It's alright in the summer maybe, although in the summer you just get a bunch of bugs come in. So yeah, the window open really isn't an option, unfortunately. Let's see if my guy said anything about his SFB. I installed the SFB 8K on 6 SA12s, ported for a customer, it did great. Most people blow the SFBs due to improper gain settings. Yeah, I imagine that's the case. The SFBs and those kind of Chinese sound digital clones are very affordable, so therefore you end up with people getting their hands on much more power than they previously historically would have been able to afford, you know, and very limited electrical supply upgrades and stuff like that. So yeah, I know that that is a big part of it, but I have like firsthand seen how unreliable those amplifiers can be and just randomly fail for no reason whatsoever. Not just the SFBs, also all of the other ones using the same build house and the same clone circuits. Yeah, they just, and when they go down, they can go down terribly bad, like very bad fire risk and stuff on those amplifiers. How's it going, Steve R? Good to see you on here, buddy. Yeah, it's a shame about Boom and Bust. Like I say, I will try and pick it up and do something different with it. Yeah, there just wasn't really enough interest, and I wasn't really getting any sponsors for it. So I think each video was making me about £40. Okay, so that had to cover the cost of the 3D print filament, had to cost the energy in 3D printing it, a little bit of my time, like setting up the print and stuff like that. Also had to cover the time creating each episode, and that was about a day and a half, possibly start to finish. I could maybe do it in a whole day if it was a quick one, or if I was banging it out. But it's like a day or a day and a half's work, plus materials, plus energy, and I was just making a loss on it. And so I was like, you know what, this isn't really working out. It wasn't really picking up. It was just kind of like staying around the same amount of viewership. So get yourself an inline fan, like a bathroom one, and then a big inline carbon filter. How long do the carbon filters last? Because yeah, I just obviously need to make sure that I change it. I saw some pictures of the new Taramps Boss series. I haven't seen Big D's video testing it just yet, but I don't know, I took a quick little peek at the guts, and what I gathered is that it is a Smart 3 base, a couple of optimizations on the PCB, plus RGB. Not a fan of the whole RGB craze, but it looks kind of cool, I guess. It'd be nice to get one in. It'd be nice if Taramps told me when they're releasing a new amplifier, and I could either buy one from them, hopefully at some kind of discounted price, or they have sent me a couple of bits over in the past, like for free. But I would never ask for something for free, especially because I'm not, when I review stuff, like I do a fair bit of reviews for Taramps, right? I actually really like the company. I like the people that work there. I think they have the right idea, the right morals and stuff, and the right customer service. I do respect them as a company, even though not every single one of their products is like super amazing. I do have respect for them as a company. So I've done bits. I've done like reviews, not for them, but of their products. Some of them have been like good reviews. Some of them have been not so good, like the head unit, for example. So I hope that they haven't been put off sending me stuff for review just because I did a bad review for them, because obviously that's what it's all about. You can make a good product, sometimes you make a good one, sometimes you make a bad one, and you just have to learn from it and move on. Right, just checking the drive transistors to make sure that they're not obviously shorted. In these kind of cheap Chinese amplifiers, when the outputs die, they can kill the drivers, and that's just the most common thing really. The drive circuit, the PWM generation circuit here on this daughter board, is electrically isolated by these two optocouplers, which is great. These are super easy to repair. If anyone ever wants to get into amplifier repair, these are the ones to learn on, because they're so easy and they're so consistent when they fail. It's always the same failures. It's so funny that there's a gate resistor over here doing absolutely nothing. That kind of cracks me up. Alright, let's just give this a little bit of power then, just make sure that it was just output FETs and that's it. How did you learn to do amps? I read Perry's guide from bcae1.com, and I just bought blown amplifiers and working amplifiers and tested them, just played with them until I worked out what was wrong with them. But I'm naturally a very good problem solver. I think that amplifier repair is not as difficult as a lot of people think it is, but you do have to have a natural problem solving mind. Like, you have to have a very logical way of thinking, and you have to be able to problem solve. Some people really struggle to kind of grasp mechanical concepts, and electricity is kind of just mechanics that you can't see. You need an oscilloscope and other things to see the mechanics behind how electricity is working, but it is just mechanics. It's like it's springs and things with inertia and dampers, and it is very mechanical at its core. So it's not as big as the Smart 3, same size as the HD line. I imagine that it's very similar circuit design to the Smart 3. They've just managed to kind of squeeze it down a little bit. Alright, let's give this a quick go then. Just going to pulse the remote, get some rail built, and oh, there we go, that came up really quick, didn't it? There we go, Class D switching. Yeah, it's good. Boop. That's a nice easy one. So, see what we've got next. Got a 500X4D. So let's get these cables off and have a look at the next one. Amplifier is kind of expensive to start with, says Sedan. So what part of it would you find expensive? Like buying the blown and working amplifiers to kind of learn the stuff, or like is it the kind of equipment, oscilloscope, stuff like that? What is it that's expensive? DG says, I restore cars and I worked out how to bash metal into new panels, but could never get my head around the small electronics. Yeah, I definitely can understand, because I was in the same position once. Like, you know, I didn't have a freaking clue about electronics. I had no idea where to even start with electronics. But something sort of clicked with me. I can't remember when or why. Something clicked with me about how electricity works, and it is very mechanical at its core. It's just pressure. It's literally just pressure, and devices that interact with that pressure in different ways. Once you start thinking about electricity like a mechanical thing, like a kinetic energy, or like a pressure, then stuff starts to sort of make sense. Well, the equipment for one, and just the risk that you won't be able to fix things. You will be able to fix things. Don't worry about buying things that are broken and not being able to fix them. Like, yeah, some things that you buy that are broken, you won't be able to fix straight away. You might not even be able to fix them for like 5 years, but eventually you will be able to fix them. Because that's what happened with me. I had loads of stuff that I picked up in the very early days of repairing, and there was some stuff that completely bamboozled me, and that I had no idea how to repair, couldn't find the faults with them, couldn't find what was going on. but I just kept them. I just kept them to the side. And years went by, and then every sort of couple of years I might come back to it, and I would find something new. I'd be like, ah, this is why I wasn't getting, you know, this voltage here, or whatever, this, that, there. And if I couldn't figure it out, I'd put it down, and another couple of years later, I'd have another look at it. And eventually, you become experienced enough through other things that you do successfully repair to be able to fix it. So don't worry about picking stuff up that you think you can't, you know, you're worried about not being able to repair it just now. In terms of the equipment being expensive to start doing repairs, it's not. It can be, but typically it's not. It doesn't have to be, sorry. You can buy used things from Facebook Marketplace or eBay. That's what I did when I got into repair. My soldering station was like £30. It was used. My oscilloscope, I got 2 oscilloscopes from a guy for £150, which was really cheap for this at the time, this oscilloscope. The bench power supply, I wasn't even using a main bench power supply for years. I was just using like a little 9-volt 4-amp adapter, if you remember, back in my early repair days. Or I was using an old computer power supply. And old computer power supplies are mega cheap. You can get them for free. People try to give these old integrated system power supplies away. So yeah. A cheap multimeter is all you need. You don't need an expensive multimeter. You can pick up like a £10–20 multimeter, just something that gives you continuity. On the multimeter, you're not measuring voltages. You're just measuring continuity, resistances, and they don't have to be accurate to the 0.001 of an ohm. They just need to tell you whether your resistor is 47 ohms or whether it's 200 or whether it's open or like whether something is short. That's literally all it needs to do. It doesn't need to be dead accurate. So you can probably get yourself set up on a workbench with all the equipment you need to start repairing stuff for like at maximum like £300, maybe even less, probably even less, maybe like even 150. Yeah, you just need a good soldering iron, oscilloscope of some kind, cheap multimeter, a power supply that has the voltage and current that works for what you're trying to repair, and then like solder, little cheap solder sucker. Bit of flux, maybe 20 quid worth of, well, you don't even need that much, like £5 worth of flux. Yeah, spare parts can be expensive, but what I would suggest you do is don't start trying to repair stuff that has 32 expensive MOSFETs all in parallel. Start repairing stuff that uses like 4 640Ns and then they're like 20p each. Right, so this amp that I've just picked out is a 500X4. So this is a Class D 4-channel amplifier. This one has the warranty sticker still intact, and a lot of these ones that I've been looking at from this company haven't had a fault. They've been no fault found. So I don't really want to break the warranty seal if I can avoid it. So I'm going to just plug it in and see what it does first before I take the back off. Because if it works, then obviously I don't need to destroy the warranty sticker, and they can sell it for possibly a bit more than if it had the warranty sticker removed. So let's just see if it powers up first. I'll start off nice and low at about 9.6 volts. Let's hit the remote and see if it comes to life. Okay. Methinks that it has a short on the output side because I hit the remote and a little bit of current draw, as you can see from the CC light here, which is flashing at the moment. A little bit of current draw and it just goes into protect. Power light is clipping, is flashing. That means that there's low voltage, and there should, after just a couple of pulses of the remote, it should have built enough rail voltage to come on. So I think there's an output side short, so let's go ahead and take the back off. I've actually been struggling to find good solder recently. So for the last couple of years I've been using some solder that I managed to buy like about 6 reels of in bulk from an eBay user, and it was brilliant stuff. I think it was 6040, and it had good flux core, and it was just wonderful. It was almost like it was low melting point solder. It was just fantastic. It flowed brilliantly, like shiny. Everything was perfect. I eventually ran out of that a couple of weeks ago, and I bought some more 6040, just cheap stuff from like a eBay shop, and it's horrendous. It's dreadful. It's crumbly. It doesn't flow properly. It doesn't melt very easily, especially with a hot air gun. It just seems to just not melt ever. So I was like, well, this clearly isn't 6040, or it's like really low quality stuff. So I sent them a message, and I was like, this is rubbish, and they gave me a refund. So then I bought some from a private user that looked like it was much better quality, had some good reviews online, and that stuff sucks as well. It's like really, yeah, just very crumbly compared to the old stuff I've been using. Doesn't seem to flow as well. It needs external flux. So yeah, I've been struggling a little bit. I also then tried to buy some, I think it was 3567, something like that, which is supposed to be way better. Like, I did a bunch of research, and they were like, yeah, once you've used this 6350, 60, whatever, 337 stuff, you never go back. And I tried that, and that kind of sucks as well. So I don't know what kind of solder I was using before that I got from this guy, where I had like 6 reels of it, but it was freaking amazing. I can't remember what brand it was or anything, but I need to get myself some more of that. Right, what we got, this is a 4-channel Class D. It is a nice basic circuit. It doesn't deviate too much from the stock layout that you'll find on the datasheet for the IRS 2092, which is what this is. So I think, yeah, like I say, I think we've got a dead output FET somewhere along here, probably, because it wouldn't power up. It would just draw a little bit of current and then go, no. So, okay, what we got? Oh yes, we have 25 there on the multimeter. So that one's shorted there. That's a dead FET. Is that the only one? Possibly, yep, and then these are the rectifiers. Yeah, just a single dead FET over here on this one. H8. Sometimes these ones are vibration damage, but it doesn't look like it is in this case. So what I can do here, because each channel, we've got channel 1, channel 2, channel 3, channel 4, because this channel still has one FET remaining, I can just cut the bad one out, and I can power it up just to make sure the drive circuit has survived. So we've still got the original FETs fitted. So if I power it up and it starts switching, oh wait, no, that one looks like it's shorted as well. We have a short between drain and source, but not between gate and source. 360, okay. Okay, so it looks like the high side and the low side FET have died, just in slightly different ways. Usually they short gate to source, but not in this case. So both dead FETs over here. Make sure that short's disappeared, yep. And these FETs are buffered by these transistors here before the drive IC. So you've got a better chance in this circuit of the drive IC surviving because it's buffered. So if the FET dies and spikes back a little bit of nonsense towards the driver, the buffers can often soak it up and the driver survives. A relatively quick way of making sure, or checking that the drive IC has survived, is just by reading across the voltage regulator that supplies voltage to the VCC, to the supply of these ICs, which I believe in this case is this U2. If you don't have a short there, then the driver isn't horrendously damaged inside at least, so you can kind of rule that out just by checking that initially, at least anyway. Let's have a quick visual inspection of the rest of it. Okay, got a little interesting mark here, but I think that's just some flux left over from the factory. A little bit of brown here. It doesn't look like a burn mark or anything, it just looks like, yeah, it's just some flux left over from the assembly process. Let's get rid of that. So yeah, not seeing any other visual damage. Just check the inductors here for any loose ones, in case vibration caused that to fail there. But yeah, maybe the user shorted the speaker terminal out, or it can just be random component failure. They're not the most reliable of amplifiers. Looks like a burnt resistor up there. Oh, that might be the orange thing that you saw. Yeah, that's just a bit of flux. How do you feel about the AAB line of amps from Def Bonds? They're the same nonsense. They're the same rubbish as the SFBs and all the other clones. I would avoid them. Avoid them as much as you can. If you want to buy a cheaper full bridge modern Class D, then get something that's designed from the ground up by the company making it. Like if you're going to buy a clone, you're going to buy like a Def Bonds on SFB, just buy the Sound Digital, the one that originally made that circuit, because it'll be way better quality. Or better still, buy a Powerus, which are currently the best ones I've seen, or buy a Taramps, an MD or a Bass series. Well, actually the Smart 8 now, the Smart 8's released now, isn't it? That's a freaking awesome amp. I haven't actually had one. I'd love to get one in to do a review of. Would anyone like an in-depth review of the Smart 8? Because I can contact my guy at Taramps and see if I can buy one from him at a reduced cost, hopefully. I'd rather not pay retail on something I'm just reviewing and then selling. Daniel says, I like Bander the best. Yeah, I used to like Bander, but honestly, I've not really found their reliability to be that great. Especially the Viking 7Ks, not that reliable. The 8Ks, I haven't really had a lot of those in, but I don't think we've got many of those over here in the UK. The 15Ks are great when they work. They're an absolute beast. Brilliant amplifier when they work, but I've seen quite a lot of failures of them. And they're using really, really strong IGBTs in the output side. So they shouldn't really explode like they do. They go down hard when they go. Actually, I've got a video that I did of a Bander Viking 15K repair. I think wait, did I? Yeah, I think I've got it. I've got it on TikTok. Yeah, relatively recently. I did a full rebuild of a Viking 15K, so you can see how bad they go when they do go pop. So Rob, I haven't actually had my hands on a single JP amp because he doesn't have any UK distributors. So he hasn't reached out and asked me to do a review of one or to send one over. I'm not going to buy one, and there isn't a UK dealer for them, so I haven't had any in for repair. So yeah, unfortunately, no comment as of yet. If JP wants to get in touch and send some bits and pieces over, then I'll gladly do a review. What about the newer Taramps? Yeah, the newer Taramp stuff, from what I've seen, is really good. The Smart 5, brilliant design. Smart 8, probably also good, but I haven't seen one yet. Smart 3 bass, absolutely fantastic as well. I'd love to see the new Boss series amp. Alright, so let's give this a little power up and see whether the drive circuit for this channel that failed has survived or not. So I've got all the power wires going in already, which is convenient. So let's go ahead and turn it on. So I'm just going to pulse the remote a touch just to build a little bit of rail voltage. And oh wait, duh, stupid as. Helps if you solder it in first before you turn it on. I put the clamp down for the MOSFET clamp first, so that like it's in position and there's no stress on the legs after they've been soldered. But almost forgot to solder it in. Because usually once I'm putting the MOSFET clamp on there, everything's already soldered, but yeah, in this case I wanted to put the clamp on first to get it into its final resting position and then solder, so there's limited stress on these legs. There we go, that'll do. The flux in this is actually very good. It's not conductive, so I technically don't need to clean the flux off, but it just looks a bit nicer, doesn't it? Alright, now I can turn the power supply on. So, where's our positive rail then? Okay, that's over this side. So this is our high side FET, as you can see, positive rail on the drain. This is our low side FET, so I'm just going to, no DC on there, which is good to see to start with. So I'm just going to go ahead and power it up fully and see if we get Class D switching. Oh, no, we don't. We get quite a lot of current draw and a very disgusting looking wave there. So something not happy over here. So we're using 2092 drive ICs, which don't offer a square wave or a PWM with the MOSFETs not fitted, so that wouldn't really help us. What I probably need to do is check that the gate resistors are intact for both of these, which I actually forgot to do, because a missing gate resistor would cause something similar to what we just saw. And then I can go ahead and check the readings on these buffer transistors, make sure that they're all okay as well, and the bootstrap diode as well for these. So let's wait for the rail voltage to sink down, and then we can just check a few bits and pieces along here. So that's our positive, that's our negative. Okey-dokey. Looks like the positive rail has sunk down to ground a lot quicker than the negatives. It doesn't necessarily mean anything, but it's worth bearing in mind. Just wait for those voltages to sink down a bit. Damien, thank you so much for the 5. That's really, really cool. Thanks for putting me in contact with Carlia Center for the recone kits. Yeah, man, you can do it. No problem at all. Glad that you gave it a go. It's not too difficult, especially with those subs. They have a nice big coil gap. You'd have to really screw up to get coil rub on those. So, have you ever repaired self-oscillating Class D amps? Yeah, most of the amplifiers I repair are actually self-oscillating. The only ones that won't be self-oscillating are where you've got some kind of clock signal being generated that's been being injected into the drive IC, either pin 3 or pin 4 of an IRS 2092 or 20957, or if you're doing something like, trying to think of ones that use a clock frequency. Most of the amps I do, like everything that's running a 21844S or 2010s or 2113s, are all self-oscillating. This one here, I believe, actually is self-oscillating as well, because the oscillating frequency depends on the kind of feedback from the FET as it kind of comes on and off, and you can actually change the oscillation frequency just by changing the gate resistor value slightly. That's how you know it's self-oscillating. But yeah, most of the stuff I do self-oscillating. Brian says, I've been running the Jensen as a sub mid-high, and I've been impressed so far. Cool. My digital scope has been acting up, so I hooked up my analog scope, and it's showing a difference in one of the input signals of the 21844S that didn't show up on my digital scope. Is that like a slight different shape of waveform, or a different height? You can force the 2092 to take or accept an external like clock. Taramps have actually done that. I think it's with the I think the HD 3000. It's not actually self-oscillating. There's a clock frequency that I think originates from the MCU, and you can make it self-oscillating by lifting a couple of resistors and preventing that clock from setting the frequency, and then it goes way higher. Let's say, for example, the standard switching frequency for the HD 3000 is something like, I don't know, 85 kilohertz, for example. I can't remember what it is off the top of my head. But then removing that resistor to decouple the clock frequency from the 2092 to self-oscillate, it ends up being like 380 kilohertz. It's like way higher. Have you still got the amp for the monitor gold sub? I'm trying to think what that was now. Can't remember what that was. How long ago was that? I don't think so. I don't have any plate amps at the moment, I don't think, in for repair, so... Slightly different shape and amplitude. Interesting. I dread the day my Technics VX500 fails. It's on the verge of failing. Why? What's wrong with it? They usually don't fail. The only thing that goes wrong with those is bad contacts in the switches and knobs on the front. Or maybe if you've got it in a vibrating environment, the solder joints go bad, but nothing really fails that much on those. It hops into protection mode every half an hour. I know how to fix that. There'll be a tiny little capacitor that forms part of the protection circuit itself. So if you want to fix that and you don't want to do any diagnostic work, just replace all of the small little aluminium capacitors, like the ones that look like this, maybe like this or a little bit bigger. Yeah, replace any small caps like that. You don't need to replace the big rail caps or any big filter caps or any polyester or film caps. Just replace the small capacitors like this on the board and you'll be back in business. I've considered making my own brand of amps, yeah, but it's much more complicated than it sounds and it seems. It's not just a case of like repairing stuff's easy compared to designing your own stuff. You reminded me to fix my Crown XTI 1000. I'm just scared to work on it with it running since you have scary high rail in them. Dude, Seddon, I'm fixing a Crown XTI 4000 at the moment. They're not that bad. Their voltages are kind of scary, but mostly on the power supply side. What would make the input signal different in one chip? The chip itself, if you're running different batches of 21844S, then they can have slightly different input impedance on that pin. So make sure that both of those chips are like from the same batch. So if you replace one, replace both, and check the resistors that lead to pin 1 from the 1A and 2A transistors at the bottom of the driver card. Have you ever seen the Taramps Base 30K? Only in pictures. I don't think there is one in the UK. Alright, hopefully the rail voltage has sunken down to a safe level now. We can poke around on this one. What we got? -5, and yeah, that's fine. So let's have a look. See whether the gate resistors are okay. Let's move this bit of adhesive away here. So just want to make sure that we've got the gate resistor here. Now, what are these supposed to be? 47. So on my cheap multimeter, because I'm in diode mode, they'll read 72, so that's fine. 72 means 47 ohms on diode mode. Let's check that one. Yep, okay, that's looking alright. So let's go back to these drive buffers here, see which one is driving. So we got that one there, these two here doing the low side, and these two here doing the high side. Okay, cool. So I'm just going to go ahead and compare readings between these drive buffers with another channel here. So on this one, this high side one here, black and red like so, we've got 611, so let's compare it to a good channel over here. Yep, that's about the same. Let's check this one over here. Again, about 611-ish. Yep, it's about the same there. 607. Yep, it's about the same. Okay, that's all reading about right with the probes that way round. Not seeing any low resistances or anything. So I think the drive buffers are probably okay. They're very rare to fail, to be honest, but it's worth checking. So now I'm just going to go and have a peek at the diode that's underneath this glue. Let's... I think I've just seen the problem here. I'm not sure how this has happened, but if I can zoom in enough. So I just went to remove some of this glue here from this diode, and actually this diode isn't soldered anymore to the board anymore. So yeah, what I suspect happened is that this is that glue kind of connected a little bit? No, not really. Interesting. So I'm not sure whether I've just caused that by trying to lift the glue out of the way, but I just gave it a little prod, and that shouldn't have been hard enough to actually cause the solder to break away there. It should have been soldered better than that. So, well, that definitely shouldn't be like that. So I'm gonna remove this. I'm gonna test the diode and then refit it, provided it reads okay. And then I might give another power up and see whether it was just the fact that this wasn't actually soldered in properly. That might have been all it was. And that's probably what killed this channel in the first place. I'm actually going to heat this up a little bit, the glue, just to make it easier to remove. Hopefully it's the type of glue that goes nice and soft when it's heated. Because what I don't want to do is to rip any pads. If it's still soldered on this pad this side, I don't just want to rip it off. Like, it's obviously loose, but I don't want to cause it to rip off or anything like that. Right, there we go. Let's just check the diode and make sure that we haven't brought pads with it. No, I don't think we have. That's good news. Excellent. Okay, so just want to try and remove all of that glue from around there now, so I can get a nice clean resolder once we've checked the diode. This is some of the most obnoxious glue actually that I've worked with in a while. It doesn't really stretch when you heat it up like some of the other stuff. And it's very stretchy, but it doesn't like to rip or come off. Very annoying stuff. So now I just need to get some fresh solder onto those pads. Trying to hold the amplifier up in a way that you can see, because it's kind of hidden a little bit under the under that inductor, isn't it, for you? So this diode might be, I haven't actually checked where it is in circuit, but it could be the bootstrap pump for the high side supply, which would obviously cause this oscillation not to work properly at all. Okay, there we go. Flux. So let's just check this diode now, make sure that it's reading correctly. Get the glue off. $426. Nothing. Yep, that's cool. That's all working fine. So we can drop that back in. I suspect it was just desoldered. Get you over there. Okay, let's hit you with some heat. I apologise that you can't really see this, by the way. It is just the inductor's just in the way. I can't really find a way to get it on camera. Nope. New try. That little bit of glue at the top there is just kind of preventing the diode from sitting down nicely against it. Let's try and get that off. I suspect when this glue stuff gets heated up, or it might actually even give off some fumes that just break down the solder a little bit. Let's give that a go. Okay, there we go. That should be nicely soldered both sides. Now let's give that a little check, a little visual. Great. Yeah, that seems okay. So what we could do now is go for another power up and just see if that was the only issue. I'm just going to check continuity on this big diode at the top here as well. Make sure that that doesn't read shorted or anything like that. Make sure that there's no shorts between any of the output legs of the 2092 here. Yeah, that seems alright. Like there shouldn't really be any reason for this not to work now. Nothing's reading bad or anything that I can see. I'm just going to check the resistors as well by these inductors. Sometimes these can go open when stuff fails. So if I can get down into one of these should be pretty low value, maybe like 10 ohms or something. 60 on the meter, that's a 10 ohm because I'm on diode mode. That's how this multimeter works. And there's another 16, so that's working fine. These little surface mount 10s all look fine. Usually when they pop, they visibly crack or burn, so that all looks good. So I'm going to go ahead and assume that that was probably all it was. So let's go for a power up attempt and see what happens. Nice low current, about 4 amps. Nice low rail voltage of about 9 volts worth of input. So let's check the low side. I need to connect my remote again. Okay, there's our high side and our low side's just here. Let's see what it does. There we go, that's better. 1.6 amps worth of current draw at idle. 245 kilohertz class D switching. So let's check that's the same on the other channels as well. 246, 248 and 250. Let's check the gate drive, check that the gate looks about the same between these. Helps if I AC couple the scope so I can actually look at it properly. Yep. Yep, that looks fine. Yeah, that's good. Let's just go up to 12 volts, make sure that it's happy at a slightly higher voltage as well. Yep, and 14. Yeah, cool. Just a diode that had come off its pads due to chemicals, smell them bad chemicals from this adhesive, crack 'em, this solder. Do you have a service manual for the XTI 4000? Yes, I found it instantly on Google. I've got the service manual and the schematic. It's very useful. However, the XTI 4000 that I'm repairing looks like it has been sat in a pond. Lots of surface mount resistors, like the solder connections are bad and they just fall off. Like, I don't think I'm going to be able to repair it, but if I do, it's going to take a lot of work because there's a lot of, like, the vias are all bad, like many missing surface mount resistors. Like, it's disgusting. It is awful. It's really bad. Powerus versus Tarabus Smart Series. I would probably be inclined to say Powerus still. Although I don't know, the Smart Series are a lot cheaper. It's a tough call. Not sure. I think it depends on the application. Hello, Florida man. Hello, Matthew. Good to see you, buddy. Yeah, cool. That's one's all good to go. I need to write that down actually on my document because I'm documenting these repairs for some people. Let's just open the docs. So this one was a base face 500/X4D class D 4 channel. So let's tell them that. Let's go to edit. This is the 500X4D, 500X4D, 1 channel dead FETs, bad solder bootstrap diode. And the other one that I just repaired was a Indie mono. What is that? What model is this? What model is this thing? Base face Indie. It doesn't actually say what model it is. Indie mono. Times 4 640N. Okay. So, next one then. Let's get the top back on this. What's everyone's favourite camera view? So obviously we've got the face and the live chat. We've got the top-down cam. We've got the hat cam, which is useful sometimes, although I find that it's not, I don't use it as much because generally the top-down cam still looks at the same thing this one does. This one can be a bit disorienting. You've also got the scope cam, which isn't working at the moment for some reason. I like this one. This one's cool. It's a good view, that one. Got the power supply, got the oscilloscope nice and big, got the constant current indicator. Matthew, yes I did. The 960 is fitted, and that's what you're watching this stream on. It's rendering the stream. And it actually fitted in the workshop PC case that I already have in here. So I haven't put my old Aspire case in the workshop just yet, because the 960 fits just fine. It's actually the same size as the 780 Ti that I was using. Exactly the same length and everything. So yeah, it just drops straight in. The 960 actually used less power connectors from the power supply than the 780 Ti, so that was cool. What's up, Artronics Lab? How's it going, buddy? Yep. Okay, next we're going to be looking at these base phase again. There's a bit of a theme with these repairs, as I'm sure you gathered. 1500 X2D. So it's a 2-channel class D. These ones did have some design flaws from the factory, but by the looks of it, they've been corrected now. So we're going to see whether this one is one of the corrected, updated ones, or whether it has the design flaws. So yeah, this is a very, very powerful 2-channel class D. Let's give it a smell test. This one still has the warranty sticker intact, so that smells like capacitor. Capacitors blowing have a very distinct smell. I wonder whether this is one of the ones that wasn't corrected. This is one of the older ones with the design flaw, because it causes the rail voltages to be too high, higher than the rail cap limit. So I'm wondering whether this one's got popped rail caps. I'm going to take the top off anyway, because it smells a bit funky. I could be completely wrong, it could just be how this board smells, but it does smell a bit like popped cap in there. Oh, man's nose knows! Man's nose is on point! What are we saying, guys? The rail caps are completely gone. Man's nose knows these things, bruh. Wow. These are the 100-volt caps as well. Sheesh. Power supply FETs are all toast as well. Damn. Alright. Well, let's get this out of the... What I might actually do in this case is I might just put a new board in, because I do actually have spare boards for these. I've got 2 spare boards, 2 donor boards for these. So it's tempting just to drop a replacement board in. The boards are repaired boards, but just because the caps are dead, I don't think I have any caps of this value, so I'd have to remove them from a donor board anyway, so I might as well just put the donor board in. I should start all future repairs with the smell test, shouldn't I? Yeah. So anyway, so why the hell have the rail caps vented? Well, it looks like we have both positive and negative rail caps vented, which is a bit less common. What I suspect has happened is the power supply might have failed in such a way to create a kind of flyback effect on the transformer in a way that caused the rail voltages to soar way above where they should have been. Either that, or yes, as Lowry correctly suggested, if the rectifier diodes fail and short in a certain way, then they can basically just let through AC from the transformer secondary to the rail caps, which is obviously not going to be a good day. And if that happens, then often it's not just the rail caps that die. We might find that we have a load of damage on the drive circuit, because if the rail caps have got AC, then so has everything else that uses rail voltage as reference, like the drive ICs and the output feds and whatever other bits and pieces. So this one actually looks like it is one of the revised boards, because this is an interesting one for you guys. Okay, so we have this is a terrible board layout. The board layout of this is terrible, and the reason for that is because we've got a drive circuit here. Okay, so you've got channel 1 and channel 2. Here's the drivers. Okay, here's the buffers for the FETs. Okay, the buffers should be as close to the FETs as possible. This channel, nice and close to the buffers, sort of, not that close, but close enough. This channel, however, bloody miles away from the drive buffers. The trace length for this massively affects the quality of drive to the FETs for this channel. And actually what they have realised that they needed to do is they've actually reduced the gate resistor value on this channel. So the gate resistors are 47 ohm from factory, but this channel they decided to mount a 100 ohm resistor on top. I don't know if the camera will zoom in enough for you to see that, but on this channel only there is 100 ohm resistor sitting on top of the 47s. You can kind of see it there. See, on this channel we just got straight 47s. This channel we've got 100s on top of 47s. That's to drop the gate resistance a little bit, just because the extra length of traces from here to here screws up the drive quality of this channel over here. So yeah, let's have a look. This has got to have dead outputs, surely. Like, what else has caused this meltdown? No way, you're joking. You are joking. No dead outputs. Alright, dead rectifiers? Must be. No dead rectifiers. What has happened here? The only reason that these caps will fail is overvoltage or reverse polarity. Did they get put in the board the wrong way round and it's gone bang the second, like during first power up? I wonder whether they were putting the board the wrong way round. I can't see any other like the output section has no dead FETs, no dead rectifiers. So unless either the transformers have a fault, shorted winds, or like the wrong spec, or I can't think why else both positive and negative rail caps would have vented like that. So let's get this out of the case and have a look on the bottom. We're going to repair the power supply and, well, I don't know, I might just drop a fresh board in here, not going to lie. Wanting to put Tiffany RCAs on my tower amps. That's super easy, my guy. Yeah, you can do that, no problem. Really easy. I actually have also removed the fixed high pass filter. I did it on a tower amps, what was it? A Smart 3 bass. Yeah, I removed the fixed high pass filter on a Smart 3 bass, and the guy, the owner of that amp, now has dead flat response down to 5 Hz. So that's pretty cool. Nice easy mod as well. Really easy mod to do. So if I get another one in, I might do a video on how to do that mod. I think it's so funny that I diagnosed this amplifier with my nose before I even took the back off. That's freaking jokes, that is. I might clip that. That's what they call it, diagnose! Eh? Nice one, Seddon. Love that. Diagnose. I'm going to say it from now on. I'm going to be like, yeah guys, we're going to diagnose this one first. So, question is, do I bother replacing all the parts in this, or do I just drop a new board in? The thing is, the boards that I've got are not the revised ones. So, I'm thinking I might actually give a go repairing this one. I didn't, so no, Token Tombstone, I didn't do any electronic school or anything. I just basically bought some broken stuff, read a quick guide on the internet, and then just started learning myself. Yeah, didn't read any books or anything like that either. Just from trial and error, really. Any tips for someone getting into amplifier repair? Yeah, buy Perry's guide from bcae1.com. One of the best things you can do to get into repairs. Token, thanks. Thanks for the kind words there. I appreciate it, man. Thank you. Right, let's get these. Well, actually, am I going to repair this, or am I just going to drop a fresh board in? The one thing that the older boards had an issue with was power supply. I think was it the dead time or the duty cycle of the power supply was not accurate, so it caused an issue with the rail limit. This is the power supply PWM board. I might actually just get the spare board that I've got for this, and just compare some of the resistor values on around the TL494. So I'm just going to pop into the loft, I think, and have a look. Although maybe I'll save this one for another time, just because this one, if I'm just going to drop a board in, that's not very exciting, is it? So I know for sure the reason that I'm not thinking I'm going to repair this one just now is because I know for certain I don't have any capacitors in stock that would work in that location. 2200 microfarads, 100 volts. I know that I don't have any that would be good there, so there's not much point doing a repair of this one on stream for you just now, because we'll get to a point and we'll just get stuck. So what I'll do is I'll go in the loft and get the spare board for that one down in a bit. But just to keep the ball rolling, we're just going to jump on this next amp that I've got, which is a 5000 XD1 X1D. Sorry, this is a monoblock. So this is basically the exact same circuit that you'd find in the SFB 5K and probably the GZCA 5000, stuff like that. It's just a Chinese sound digital clone 5K. So we're going to take a look at that one next. If you're going in the loft, check to see if you still have that monitor gold plate. I don't know what that was. I don't have any no monitor audio. I think I repaired it. I think that was a what? Wait on a minute. Where have you seen that in my videos? Was it? Did I do a video on it, or did I repair it, or was I struggling with it? What? Where do you know that from? Because I definitely don't have it here. There's no plate amplifiers in the loft. There's a couple of plate amplifiers here, but they're mordant short. Oh wait, hang on. No, maybe I do have a monitor audio plate amp here that I was struggling with. Or do I? Or was that Kef? Can't remember. I'll have a look in a minute on my racks. Oh, you've got better memory than me, Cyrus. The sub's up for grabs if you're interested. Which sub? Is there a sub on eBay or something like that? You did fix it. I was fixing one, but the drive chip was balked. Oh, okay. Okay, so this is a... Oh yes, there's plenty of damage in here. This is a 5K sound digital clone. We have cooked up power supply to the point where it's caused a fire and damaged the fan. So this fan will no longer spin because it's melted, although it will spin if I just cut away the melted plastic there, but that's been on fire. The amp's obviously been mounted in this orientation like this, because the flames from the fire have gone up here and damaged the fan there at the top. We have more power supply damage over here. Actually, I think I can see the reason that this amp probably failed. Let's take a look together at this. So if we zoom in a bit here, you should be able to just about make out on this MOSFET leg there is a little wire strand, a little bit of copper wire strand just here. Yeah. So whether that was there on that leg or whether it's moved from somewhere else and caused something to short out, that's probably what killed this amplifier, wire strands. I have a smart 5K Taramps. It's not a tar amp. It's a Taramps. That's the brand. Sorry. It slightly gets to me a little bit when people say, "Yeah, I've got a tar amp or a Tara amp." No, you've got an amplifier made by Taramps. Which one would I pick over that or the WXD D5KG2. Don't think I've heard that. But yeah, I would absolutely go with the Smart 5 because it behaves like a much bigger amplifier than it is, because it's basically, the Smart 5 is basically like an 8K amplifier with a current limiter. So provided your impedance rise is high enough, it's going to behave like an 8K amplifier, and it's kind of bulletproof. It's kind of idiot proof, because you really struggle to actually kill it from overcurrent or anything, because it's always monitoring that. So I would definitely do the Smart 5. How timid were you before you took on boards with high capacity capacitors? Well, the amplifiers that I started learning on were Bander Viking 7Ks, which have really high voltage, high capacity rails, so I pretty much jumped in at the deep end on that. I was going to ask the original owner for the sub. So I'm really struggling to remember that. How long ago was that? Can't even bloody remember. I think I must have just... Yeah, I think he must have just paid for a repair, because I don't think I have it anymore. If you've got a ZV612, you want to be considering a Smart 5 rather than a Smart 3, in my opinion. I haven't personally heard of any issues with the Smart 3 base wired to 0.5. It's designed for that, so... But I would probably just look at a Smart 5, just for the headroom more than anything. Smart 3 would be fine as well. You don't need 5 kilowatts, you're absolutely correct. However, having the headroom there to allow up to the kind of sine wave voltages that would exist with a 5K amp, even if you're not clamping 5K, let's say you've got really high impedance rise at a specific frequency, well, with the Smart 3 you might actually clip, even though you're only clamping like 1200 watts, it might actually, the sine wave might reach the rail limits. So having the Smart 5 just basically means that you know for sure that you're always miles away from the rail limit, which is where it clips. The amplifier is going to be running cooler, you've got more heatsink thermal mass, it's just all over a better experience. You've got much more headroom there thermally and electrically, and it will be running more efficiently as well because it's not being run close to its limits. So that would be my advice. The Smart 3, okay, what you need to understand, this is the problem with dyno videos. You're taking too much from a dyno video and you're misunderstanding it. The Smart 3 base does big numbers dynamically. That's because the tiny pulse of signal that's sent into the amplifier on a dynamic test is too quick for the amplifier's smart circuitry to react to. So basically the Smart 3 base is not a 3K amplifier at its core. It is more like a 5 or 6K amplifier, maybe even more. So it does, naturally, without any of the smart circuitry, if you disabled all of the smart circuitry, that amplifier is good for 3000 watts RMS at 2 ohms. Naturally, as you drop the impedance by half, the power, theoretically on paper, would double, but it doesn't because of trace resistance and stuff like that. So basically that amplifier will try and make 6K at 1 ohm, but it won't. It'll be more like sort of 5K at 1 ohm, and then at 0.5 it will try and make 10K, but obviously it can't. It might do more like sort of 7K or something like that. So on the dyno videos, the dynamic power that you're seeing is the power that the amplifier would try and make wired to that resistance without the smart circuitry being active, because that tiny little pulse is just too quick for the smart circuitry to react to. However, as soon as you're playing music and stuff like that where the smart circuit is actually reacting as intended, you're not going to be getting those numbers. So the dynamic figures from those smart amplifiers you might as well just disregard, because you're never going to see that in a real world environment. I'm just cleaning up this fan here. I'm just cutting away the carbonized plastic here so that the blades can spin freely once more. There we go. Oh, you were talking about the certified tests. I didn't think that they did more than like 3K, because that's what the amplifier is supposed to limit itself to. If I'm honest, I haven't really seen the dyno videos in recent times of the base 3K. But I do know that they do crazy power dynamically because of the smart circuitry being a bit delayed to come in. Yeah, they should really sort of limit themselves to 3.5K certified, because that's the whole point of the smart circuitry. Right, there we go. Fan spins nice and smooth again. Okay, are we coming out? Yeah, here we go. Nice. Okay, so why did you fail then, Mr. 5K? I suspect we have dead output FETs, but not always. So nothing over this side. H9s are 4227s. Okay, no dead outputs. So just a power supply failure. Could have been a reverse polarity connection. It's quite uncommon for these to go down just on the power supply. Now, the risk of these is that sometimes when the power supply fails, it can kill the MCU, which naturally we really don't want to happen, but it can happen. So we're going to cut all of the stanky dead FETs out here. Can you fix? Yes, I can fix pretty much anything. Provided it has an intact PCB, traces and vias, I can pretty much fix anything. The only things which generally aren't repairable are things that have been sat in a pond where all of the traces and vias are just completely eaten away, and then it's not worth it. Would you recommend ordering Tiffany inputs? No, I wouldn't personally. The RCAs are fine by themselves. There's no audible or operational benefits to using Tiffany connectors. Yeah, they're nicer, they're better quality, they'll last longer, but there's, as long as you're not yanking on the amplifier and swinging it around by the RCAs, there's no point really upgrading to Tiffany's. It's nice. It's nice when an amplifier comes with them, for sure, because then it's come with them, and you haven't got to do anything. Then it's cool. But there's no point like wasting your time replacing them and swapping them out for Tiffany's, because there's no benefit unless the RCAs are already broken and you're changing them anyway. Then you might as well replace them for Tiffany's, because you're already doing that work. But there's no point just replacing them for Tiffany's for the sake of it. Yeah, like I say, if your amp's already got loose RCAs and you're going to need to do some work on them anyway, you might as well replace them for Tiffany's, but otherwise just leave them as they are. Strictly Amps, good to see you, my man. How's it going? Yeah, it is a shame the Boom or Bust series didn't take off. Like I say, I might give it another go. I know that sometimes it takes time for things to kind of kick off on YouTube, but it was costing me more than it was worth it at that time. I think probably what I'll do is, if repairs quieten down a bit in January, February, which they did last year. Because sort of January, February, March time was very quiet on repairs, and I was a bit worried about, I was like, shoo, is this the end of days? But it picked up again. But yeah, if it quietens down again in the winter time, then I might do a second series of Boom or Bust to fill the time. I think for me to make Boom or Bust work, it either needs sponsors, or I'd have to do it as like a YouTube membership only series or some bullshit like that. Like, I don't want to do that, but it's very time consuming to make and costly to produce the stuff for. So unless it was getting like 50 to 100k views per episode where it pays for itself, if it's getting like 15k views, then I need some other kind of support for the episodes. Yeah, maybe season 2 will be better, yeah? Who knows? We'll have to wait and see. Oh, I'm glad that you liked the video I did on running amps in electric cars. Yeah, I thought about that video for a while. Something that I've been wanting to make for a while, so I'm glad that that one was one that you enjoyed. For me, it'd make the sense. Why only 3 rail caps? Shouldn't it be 4? Nope. This amp uses a single positive rail voltage, so all the caps are in parallel. There's no positive and negative rail, it just has a positive rail. My favourite video you made was one comparing the JBL to Taramps on music. Yeah, that was a cool one. I wasn't sure how it was going to go. I thought I might hear some differences because I really like the JBL amplifier a lot. I have a lot of respect for it. So that video was just going to be, it was either going to be, hey guys, there's really not that much difference between amps in subwoofer frequencies, or it was going to be, hey guys, there's a massive difference in amplifiers between at subwoofer frequencies. Like, I wasn't sure how it was going to go, and yeah, I found out that really there wasn't that much difference. Can the Smart 8 handle 16 volts? You don't need to run 16 volts on those smart amps because they have a regulated power supply, so you're not getting any benefit. There's no need to run 16 volts on the Smart Series amps. Doesn't make it any better, really. If anything, you're just stressing the components more inside. Run it at 14.4 and you'll be fine. Alright, so this is now ready for some new FETs, but obviously we haven't done any other work on it at all yet. We need to do gate resistors, we need to check that the MCU is okay, check the power supply drive IC is okay. Can also clean this board up a bit because it is looking very crusty and burnt from all of that smoke. Get you cleaned up here, and then we can actually have a look at the gate resistors, because if none of the gate resistors are bad, then no current made its way back to the driver, so the driver will be fine. So I'm not seeing any dead gates on that other side yet, just at a quick glance. So this could have actually been like a reverse polarity type situation, or just a wildly high overcurrent situation. I mean, we've got to have at least one dead gate resistor surely over here. Right, where's the power supply driver? That is going to be over here. I believe it's this one, C2. That's going to be our power supply drive IC. So let's just have a look and see whether we have any dead gates on this side. So we're going to go gates here to here. Ah, yes. So that one's okay, but we have a dead gate resistor there. That one's okay. This one's dead. That one's dead. Okay, so yeah, I've got a whole load of gate resistors on that side, and probably some as well over here. Yeah, but pretty much all of these are dead. So I imagine that the drive IC took a pretty big hit. We'll have to check it. Once we've fitted some new gates, we'll give it a check. We might be okay. A quick way to check as well actually is if the 10 ohm resistor in line with VCC is open, which it's not, so it hasn't drawn excessive current from its supply line, so it might be okay. So let's start by removing the bad gate resistors. There's one here. These are 10 ohm gates on this amplifier. And there's another one here. Another one here. There's probably another one at the top there as well, under the glue. And these three there are okay. So a bit of flux on these pads and we can drop in some new gates. 1, 2, 3. And then over this side, probably got this one bad as well over here. There we go, just uncovered that resistor down there at the bottom, just underneath this capacitor here. You can see that there, that one needs coming out as well. Okay, and then flux. And then some new resistors. Find some 10 ohms. Trevor says, in all capital letters, change the C2 or C12 MOSFET and the 10 ohm resistor. Well, in this case, we might not need to change the C2 drive IC because it appears to be reading okay, but we can change it if not. We need to change the MOSFETs, the 10 ohm gate resistors, possibly the drive IC, and if we've got really unlucky, we'll need to change the MCU. One, two, three, 4 on this side. And 3 on the other side. 1, 2, 3. There we go. Thanks Vladimir for the kind words. Yeah, that was a nice fix on that Rockford. It was quite lucky, didn't have any extra issues after I just replaced the visibly bad components that I found, so that was nice. Alright, new gates fitted. So now we can plug some power into this and see if the driver's survived. Zoom out a little bit, drop in some power wires, see what she's saying. 12 volts on this side. Let's go in there. Ground on this side. And a remote. Very good, very nice. So we might get some current draw without even applying the remote, and if we do, then that's a sign that the driver has failed. I'm just going to go ahead to the underside of the board here just to scrape between the pads here, just to make sure we don't have any solder bridges from where we would be soldering those MOSFETs. Sometimes you get little strands that can sit in between the pads as you desolder. Looks alright to me. On the back here, okay. Alright. So, a bit of power on the supply. Okay. No idle current draw that I can see. It says 0.1, but that's just this power supply. It's not calibrated properly on the current meter for some reason, so it just says 0.1 at all times. Okay, so just checking for DC on the gates. We haven't applied the remote yet. Just I don't want to see any DC there. Okay, good. Right, now I'm just going to apply the remote, and I want PWM and no DC. There we go. Beautiful. Let's give you the scope cam. So we have some very small pulses. I don't know if I'll be able to get my scope to focus in on them because they are just very, very small little pulses for health check mode. Yeah, I don't think my scope will focus on them because they're so small. Messing around with the settings here just to see if I can get it to trigger on these. There we go. Okay, I just need to turn the level up a little bit. Yeah, can't really get much of a visual, but you can see that they're there. You can see that they're going up to just about 10 volts, which is where we've got our power supply voltage to. So that's correct. So we check bank 1. Uh-oh, bank 2. Now that is not high enough. That's not a good sign. So you see bank 1, nice and high. Bank 2, not high enough. Let's check on the other side. Bank 1, nice and high. Bank 2, not high enough. That's a shame. So that could be this driver over here on the board, if we zoom in a little bit. And I'm hoping that it's not the MCU. So let's check the inputs from the MCU to the driver and check the amplitude of those. Okay, so we're just above the second line on that bank. And this one. Okay, phew, the MCU is all good. So we just need to change the drive IC here. Not a problem, easy. One half of it was fine, but the other half not so much. Christian says, fix my first amp, gas 1K, class D. Nice, good job my friend. It's really good feeling, isn't it? Really satisfying feeling repairing stuff. Okie dokie, and a replacement. What have I done with my replacements? Where are my flapjacks? Where are my replacement MOSFET drivers? Can't remember what I've done with them now. In one of these drawers. Regs, drivers, power supply. Nope, not in that one. Maybe in here. I think this is what I'm looking for here. Helps if I label my drawers, wouldn't it? Yep, that's what I'm looking for. FAN 3227 is going to be my cheeky replacement right here. Okay, so now, hopefully, we have equal amplitude PWM on those power supply gate pads. So let's have a look. Okay, so yep, just above 10 there on bank A. Bank B, there we go, that's what we want to see. So yeah, bad drive IC now replaced, and now we're ready for some new FETs. Let's grab some H1s. Yeah, the hot air gun, the nice long nozzle is really good. It's a bit of a lifesaver, really helpful for videoing and getting in tight spaces. Highly recommend it. So I'm just going to drop some FETs in here real quick. I'm going to lock off this stream at 7 PM, which is currently in 6 minutes. So I've got 6 minutes to get these FETs in and get it tested. Yeah, the JL Audio amplifiers are generally pretty good. There's a couple of series that I don't really like from them. Not a huge fan of the XD series. It was a bit of a money grab. I think the HDs, what is it? No, sorry. I think the what is it? I think the HD series are ridiculously overpriced. They are very good amplifiers, but my god, why are you spending that much money on a freaking 500 watt amplifier when you can spend the same money and get like 8,000 watts and have headroom? I get that not everybody needs 8,000 watts, but there's a happy middle ground somewhere. Save your money, you know. And JL Audio is better to buy second hand. Buy it second hand. Don't pay the retail price. Let some other guy with a big deep pockets pay the retail on them, then buy it second hand. Yeah, it'll sound great on your doors, Matthew. Honestly, yeah. JL Audio amplifiers for your doors, lovely stuff. Really nice low floor noise, nice sounding amplifiers, should last you a long time. Can't really go wrong. Right, what are we saying, guys? 3 minutes to solder these in and get it tested. Sure we can do it. Oh, I've got 1 minute left. It's alright, if we go over a little bit, it's fine. I feel like this is amplifier repair speed run. Okay, there we go. Soldering iron off, little brush. Right, let's test it and see if we have operation and Class D switching. I'm not going to test it for audio just yet because I don't have time, but we're just going to make sure that it produces Class D switching, nothing goes pop, etc. Okay, rectifiers, probably good. Output FET's all read good. Get a bit of dust off there from the fans. Right, so we have 6.6 amps going in. There we go, we've got some rail voltage getting built now in the output section. We have 64 volts, 64 and half rail on the low side. So these low sides are the ones we're going to be looking for our Class D switching on. So let's go all the way and see if we get our Class D switching. Ta-da! There we go, fantastic. Class D switching, 1.8 amps worth of idle current draw, and let's just check the other side. There we go, fantastic stuff. Up to 12 volts, yep. That is a repair, my guys. Lovely stuff. Thank you so much for joining. I hope you enjoyed that. It was a bit of a random, spontaneous live stream. Didn't actually plan to stream today, but thought I might as well because I had a bit of spare time. So, guys, check out my TikTok if you are on TikTok. If you're not on TikTok, then don't download it because it is a rubbish, nonsense, horrific app. You don't need it. But if you already have it for whatever reason, then follow me on TikTok anyway. Watch my YouTube videos. I'm going to be putting out some repair videos like the Rockford Fosgate 4 channel that I just released today. I'm going to be doing more of that kind of more relaxed content, more like just taking my time so you can see every step, all the soldering, that kind of thing. I'm going to try and pick up on the streams again if I can. Really busy time of year this time of year for me, but maybe in December we'll do some streams. Probably won't be able to do Streamless again. That was really intense. Didn't get much sleep that month, but it was good. It was good times, but maybe not. Guys, have a great evening. I'll catch you all in the next one.